So let's see if we can apply this idea of these graphs to their word problem. All right, so here's their word problem here. A store sells trampolines. The table shows the number of Y trampolines sold during the Xth year that the store has been open. So these are X, Y points. But they want us to create a scatter plot of the data pairs like this. They want an X and natural log of Y to show that an exponential model should be a good fit for the original data pairs, X, Y. All right, so here's what we're gonna do. My X's are all gonna stay the same. So I still have a, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, those didn't change. It's now the Y's. I don't have straight up Y now. I have natural log of Y. So these Y's, I have to take the natural log of. So I need like natural log of 12 and natural log of 16, natural log of 25. I'm doing natural log of each of these guys. At the X value of 4, I had straight up 36, but I'm gonna do natural log of 36. All right, each of these Y values, I'm taking the natural log of. Okay, so if I'm going to do this like their graphs up here, I probably am going to try to get like the decimal form. I mean, if I'm trying to figure out where this is on my graph, does anybody actually know where natural log of 12 is in the graph? Yeah, probably not. So we are going to, let's figure out the decimal form of this. So I'm gonna do a first few. In my calculator, I do have an ln, I have a natural log button on my calculator. So I'm gonna do my ln, my natural log of 12. And I think they were rounded to 2 decimals. So let's do that. I'm gonna get a 2.48. Okay, so instead of my natural log of 12 decimal form, 2.48. All right, and then let's do this for my natural log of 16 now. Decimal form, if I go to 2 decimals, I'm going 2.77. All right, so let's have you guys bust out those calculators. Bust out those calculators, and I'm gonna have you guys put this in here. So find that natural log button. All right, and then, so let's see here. Jordan, I'll have you do the natural log of 25, like my next one. And then Jason, I'll have you do the natural log of 36. I need the decimal form rounded to 2 decimals here. Anna, I'll have you do the natural log of 50. All right, Casey, I'll have you do the natural log of 67. And last one here, this is natural log of 96. So Alexa, can I have you do the natural log of 96? Let's round to 2 decimals. Just type it in here, let me know what you got. Nice, Anna. So your natural log of 50 was a 3.91, nice. All right, hopefully, Jordan, nice, Casey. Casey, yeah, you're doing the 67 actually, so you're doing this one. Casey, natural log of 67. All right, Jason, you did the natural log of 36. You got 3.58, looking good. All right, Lexi, for the natural log of 96, this last one here, you got 4.56. All right. And then let's see, Casey, you did the natural log of 67. Okay, got a 4.20. Let's see, is Jordan there? All right. So Jordan, you're doing this one. You're doing the natural log of 25 in your calculator. And round to 2 decimals. All right, so I'm going to plot these points while we're waiting on that one. I'm just going to start plotting these points. Let's see here. I went x value of 1 and y value of 2.48. So like almost 2.5, almost like 2.5. There we go. And then a little past that, I got my x value of 2, y value of 2.77. Okay. So once I get to Jordan's there, I'll plot that point. This one is the 4 x value 3.58 for my y value. Oh, thanks, Jordan. So Dylan, which one are you talking about? So let's see, 5.8, a little past my 3.5 here. Oh, okay, so just the rounding. So am I supposed to round up to a 3.22 or do I leave it at 3.21? What do you think, Jordan? Is it a 3.21 or 3.22? Do I need to put this in my calculator? Let's see here. Natural log of 36. Oh, Jordan, so you did round it up? All right. Oh, you're good. So yeah, oh no, 36, natural log of 25, sorry. Nice, so yeah, 3.22. All right, there we go. Okay, let's plot these. Let's see, 3.22, a little less than 3.25. Like 3.25 is a quarter, right? So 3.22. And obviously I'm estimating, this is supposed to look like it's in a straight line and mine hasn't been a perfectly straight line. But let's see here, I've got, my next one is x value of 5, y value of 3.91, so a little short of a 4. And then we've got a x value 6, y value 4.20. Let's see. There goes a little past my 4. And then let's see, 7, and then 4.56, so a little over 4.5 here. There we go. So again, I'm not all that great at this perfect points here, but let's see, if I connect these, it should look somewhat like a straight line. All right, so that was more like this guy right here. I plotted my x and then natural log of y points, and it ended up as a straight line. If I just graphed the x, y points, like all these guys, the x's and the y's, it probably would have looked like that exponential curve. All right. So do you guys have any questions on this graph before I move on to part B? For us, we don't have any questions on this. You guys can totally do it like on your own on the homework. Oh, thank you, Kenry. Thanks, Hannah. So why do we have to put it in that form? Okay, so the reason why mainly is because you know how the exponential growth, it like gets really big really fast. Like this just kind of takes off, right? It's kind of hard to see the rest of my graph. So linear graphs, though, it is a little easier to see. It doesn't like shoot off to where I can't see the rest of it. It makes it easier to kind of see everything. I guess that's kind of an advantage of drawing it this way. Other than that, that's probably the only reason I would do it. Hannah, does that answer your question at all? All right, cool. Any other questions? I heard a couple people are doing good, but I haven't heard from most people, so I'm a little nervous. When I don't hear from people, it makes me think that we're not paying attention. Awesome. Thanks, Jennifer. Thanks, Anna. Thanks, Adriana. Thanks, Casey. Darren. Quiet noises. There you go. Thanks, Maddie. All right. All right, so if we're good with this part A, I'm going to move on to part B then. So this is, they want you to write an exponential model for the original data. So here's their little hint here. This exponential model usually is like a times b to the x. This is what we talked about exponential equations. This is what we talked about before, yesterday. But they want you to kind of do this other format. They want a natural log of y. And when I used a natural log of y instead of a plain y, it ended up looking like a straight line. So we're going to actually go with one of those equations that we should be somewhat familiar with for straight lines. So here's this equation. This is kind of our hint here. This equation used to look like, for a line, it was y, not the natural log of y. It was just straight up y minus y1 equals m times x minus x1. Yeah, so this was a point slope equation, They just replaced the y with a natural log of y. So hopefully this formula looks pretty familiar, probably freshman year. You guys looked at this formula. So we're going to write this equation for our line up here. So I can pick really any x1, y1 point. It honestly doesn't really matter. So let's see here, Maddie, will you pick one of these points? I don't really care. But I gotta pick one of the ones off of my x and natural log of y. All right, so Maddie, pick one of these guys. All right, 2.48. So like basically our first point here is this is gonna be my x1, y1. Okay, so that's what I gotta plug in for my x1 and y1 on this equation. All right, so yeah, my x1, we're putting a 1 in for that, and a y1 is that 2.48. The natural log of y stays natural log of y. And I took the y value that you chose, 2.48, equals, m. I don't think we found the slope of that line quite yet. So I'll leave that blank for a sec. And then I've got x minus my x1, which we chose our x1 is the number 1. Okay. All right, so I plugged in my x1, y1 so far. I still need to plug in my slope, my m. Does anybody actually remember the slope equation from freshman year? Probably a while ago. Do you guys remember m equals, it's like a big fraction. Do you guys remember this equation at all? Oh, so Henry, that is an equation that uses the slope. That's like slope-intercept form. It's like an equation for a line. Okay. Oh, nice, Adriana. So yeah, that's the equation that I would go with. So y2 minus y1 over x2 minus x1. So like the y's go up and down. This is like rise over run. The y's do the rise up and down. The run are my x's. This is basically a formula to get my rise over run to get my slope. All right, so I'm gonna use that formula on, let's see, we already picked a point number 1, didn't we? We already have like a x1, y1. So I'll put those in here for my x1, y1. I still need point number 2. I need like a x2, y2. So again, you can pick any 2 points. These are all on the same line. Doesn't matter which 2 points you pick. So like, Jennifer, which point do you want to be the second point? Like I said, it doesn't really matter, just pick one of them. 3.22, so like the XY point right here, a 3 is my second X, and the 3.22, that is my second Y, so my Y2. There's my X2, Y2. Okay, so then I actually have all 4 numbers that we need now. And like I said, if you guys picked different points, you should be fine. You should get the same, excuse me, the same slope. All right, so my Y2, we already identified the Y2 is my 3.22 minus Y1. Let's see, my Y1 was 2.48 over X2 minus X1, so 3 minus 1. All right, so I will say that I want a single number divided by a single number. All right. Let's do the 3.22. Oh, maybe if I turn the calculator on. There we go. I'm doing my 3.22 minus the 2.48. All right, so the numerator is a 0.74 messy. That's fine. I'm now going to divide by 2. And I'm getting my slope here, 0.37. Okay, so here's my m. That should be multiplied in front of these parentheses with the x, my 0.37. All right, and this actually is my final answer. That's the equation that they were going for. All right, so do you guys have any questions on this part B? Oh my goodness. Oh yeah. You guys got anything on this one? Jaden, you're good? Okay. This is kind of a different type of question. You guys really don't have anything for me? Think you got it? Okay. All right, sounds good. All right, well then I'm gonna move on to these last 2 problems, which are very similar to what we saw yesterday, where they actually don't want me to write it as a line. They want it to be written as an exponential function. They want the y equals a times b to the x. And they give me 2 points to make it pass through. So Hannah, was it pretty dang close? So if you chose 2 different points, you got a different slope than the 0.37, but was it really close to 0.37? 0.29, okay. So on your homework, I think these are multiple choice ones. So as far as the multiple choice goes, I would look at I think it's graphs, if I remember correctly. I would look at the graphs and see, you know, if my slopes are pretty close, then I should be able to identify down to which graph is most likely. Does that make any sense? Okay, cool. Okay, good question. Oh, Jonathan, you're good. Okay, so I'm gonna look at number 2 and number 3. So write an exponential function whose graph passes through the given points. This should be very similar to what we did yesterday. And so 212 and 324. If you really want to, you can plot it on your graph. Here's my 1, 2, all the way up to a 12. And then 3 goes up to a 24, doesn't it? Whew. So it gets pretty sharp. They only gave me 2 points, but I do know the basic shape of this graph. This graph should go and curve like this. It should not pass my y-axis, so I don't have any negative y values. This is what it's looking like. And so, Adriana, I wanted to talk about your question here. On the homework, they could have given me 2 other points on this, and it is possible that I have a negative x. So they could have given me like a, I don't know, -2 with this tiny little y value, they could give me this negative x, but I should not have had, oops, I should not have had a negative y though. My graph did not go down here at all. And so, Adriana, the negatives that you got on one of the homework problems, weren't they negative x's, but they were positive y's, right? Yeah, okay, perfect, which is what this looks like to me. It looks like I can have negative x's over here. I just can't have any negative y's in this graph. All right, so in that case, I would still approach it the way I'm going to now. I just would have to deal with my negative x's. So how I'm going to approach this is I'm going to make a system of equations. So let's see here. I'm going to erase my graph here. I've got my first x and my first y. So I'm going to put those into my x and y here. So I've got a 12 equals a times b raised to the x value, which is a 2 in this case. All right, so I put this xy point into my equation, and I'm actually going to do pretty much the same thing with this xy point. My x in this case is a 3, y is a 24, so I get like 24 equals a times b raised to my x, so raised to the power of 3. So here is my system of equations. I've got to make these two separate equations. They've got to work together. Okay, so I think you've got a couple options. I'm going to show you how I would solve it. If you do it differently, you could still get the same answer, but I'll tell you how I would start it. I would probably take this equation. All right, and I want to solve, I think I would solve for a. Personally, because the reason I would solve for a, I have to divide the b squared over. So I get like 12 over b squared equals my a. You could, if you wanted to, you could solve for the b. It would just have an extra step. Like you would have to divide the a over, and then you would have to take a square root to get rid of your squared exponent. So you would have an extra step there. That's why I kind of went with solving for a. But like I said, it's not like there's only one way you could do this. There's multiple ways you could do this. Since I know what the a equals right now, that's the a from my first equation. I'm going to plug that in for the a in my second equation. All right, so the second equation said 24 equals, and then I'm putting in for the a, I'm putting this 12 over b squared times b cubed. All right, so the nice thing is these are all b's now. I don't have any two variables. I have a single one variable in that equation. So this, I do have to be able to use my exponent rules. All right, so let's brush up on your exponent rules. The exponent rule was if you have, let's see, I think we wrote our rule like this. If you have the same base, but raised to these other exponents and they're being divided, then I could subtract n minus m, the exponent in the numerator minus the exponent in the denominator. So that rule, if I use that here, this is like a b cubed over 1, like this is in the numerator, and then b squared in the denominator. So I'm going to simplify this down by subtracting the numerator, the 3, minus the exponent in the denominator, 2. 3 minus 2 is 1. So I've got like 12 times b raised to the first. And really, do I need to raise it to a power of 1? Not really. It means I just have one of those b's there. That's fine. Okay, and so now I will divide by 12 on both sides. All right, I got what my b equals. B equals 24 divided by 12, so 2. Yes, okay, so game plan in my head, what I'm trying to do is I'm trying to find what the b equals. I'm trying to figure out what the a equals, and then I'm trying to plug those into this equation. As of right now, I have a number for my b. I don't have a straight up number for a though. So I think that's my next goal. So Gideon, you're saying, okay, so you're good with that now? Were you good with the A then? My goal on the A is to get like a single number. So I'm gonna put what this B equals, I'm gonna put it into this equation. And this is gonna be now my A equals a 12 over B squared, and my B is a 2, like I've got a 2 squared. Let's see, 2 squared is 4, so it's like 12 divided by 4 is a 3. All right, my A is 3, good. I've got the two things I had to find. I had to find the A and the B, so I could put those into this equation. All right, so that means y equals the A, which we just found is a 3, times the B, which we found was 2, raised to the x. So y equals 3 times 2 to the x. All right. And I think what I would do to check my answer, make sure I got it right, I would pick one or both really of these points and make sure it actually works in there. Like if I did 3 times 2 raised to this x value of 2, like 3 times 2 squared, I should get the y value 12, which I think that works here. Like if I put my x and y in here, if I put my 12 equals 3 times 2 squared, yeah, that's true. Like 2 squared is 4 times 3, 4 times 3 does equal a 12. Okay, so that helps me check and make sure I got it right. I could even do that on this other point as well. If I put my 24 in for the y, 3 times 2 to the power of 3. So let's see, 2 cubed is 8, and 8 times 3 does actually equal 24. Okay, so I can check and make sure that I got this equation right. All right, so what other questions do you guys have? Before I have you guys try one on your own, I'm gonna have you guys try number 3 on your own. But before you try it on your own, what kind of questions do you have? Nice, good question. Yes, if you started out with this second equation, so on how I started this one, I took my first equation and I divided the b squared over. So if here I'll put this in another color. If I took the second equation, if I divided my b cubed over, I got 24 over b cubed equals my a. And then I would have to plug that into this first equation. I would get the same a and b. I would have done it a different way, but I should still come up that my b equals a 2 and my a equals a 3. All right, so Gideon, that's a good question. You can totally do it a different way and get the same answers. And you can check it too, yeah. You could take your original points. I would check it the same way that I did before. Like I would take these points and plug it into what I think is my equation and see if it actually works. All right, good questions. What else we got, you guys? Any clarification we need before you try the last one? Frills, you guys are good to go. All right, let's see. Let's see if we are good to go. I'm gonna separate this here for a sec. All right, thanks, Julian. So I'll have you guys try number 3. You can do this very similar. We did this yesterday. We've tried it a bit today. I want to see if you guys come up with this final answer. That final equation. All right, so I'll give you a couple minutes. Once you guys do get your final equation, will you just type it in here so I can see what you got? Normally I would walk around the classroom and see what we all got, but I can't really do that right now. So if you guys could just type it in here, it's just a private message, nobody else can see it. So just type it in and let me know what you got.